Business Intelligence. Today is the 7th of November. For the record, only 3 students are in the virtual room today. Okay. You are asked to download this paper. Okay, go to this address here. This is a conference paper I published in 2015. This paper is part of the exam, okay? So you need to understand, download, this is open access, download and study the paper as well. Okay, what we see today is a little explanation of the main concepts, but you need to study it all. Okay, so today we look at a concept called nemawashi. Okay, this comes from Japan, means prepare the ground. Okay. The hypothesis is that there is a list of KPIs those are key performance indicators given with values at different time points. Okay. So basically we have a list of KPIs. KPI sub E as a function of time. E is 1 to n. We are going to devise a method to understand and visualize this method. Visualizes the dynamics of the organization through its KPIs. Okay. And the best thing is to do so with an example. Okay. So, and with the example, you can see what we mean with that. As I said, you have more insights in the PDF above. Example: a KPI system is 3-dimensional. And has following data. Quality measured in parts per million. This is the number of mistakes per million produced parts. Delivery rate measured in percent, how many deliveries are correct in percent, and cost measured in euros per part. Okay, and then we have the calendar week number 1, calendar week number 2, calendar week number 3, calendar week number 4, and calendar week number 5. So we have gathered some data. Three 300, 2700, 1800, 1500, 1300, then 91, 93, 89, 92, 95, and then 17, 18, 16, 15, and 16. Okay. So the first problem that we see is that this column is in the thousands, this column is almost in the hundreds, and this column is almost in the 20s. So the first step is to normalize. Okay, so normalize is done with different methods, but the way we will do is we take the value, we subtract the mean, and divide by the standard deviation. The second method, which we will use, so this is the first method. The second method, which we will use today, is to take the value, subtract the minimum of the time series, divide by the maximum minus the minimum. Okay, so we will use this one today. Okay, so in order to do so, we defined new data set. Calendar week 1 is 3,300 minus the minimum value of the rate of the time series, which is 1300, divided by the maximum value, which is 33 minus 1300. So this delivers 1. Okay, for calendar week 2, same thing. We take the value, 27 minus the minimum value divided by the maximum value minus the minimum value. This delivers 0.7. For calendar week 3, it is 1,800 minus the minimum value divided by 3 minus the minimum value. and this delivers 0.25. Then the calendar week 4, we have 1500 minus the minimum value divided by 33 minus the minimum value. This delivers 0.1. And calendar week 5 is 13 minus 13 divided by 33 minus 13, and this delivers 0. You see, this method of normalization takes all the data between 1 and 0, and the maximum value is transformed into 1, the minimum value is transformed into 0. Okay, we perform the same for the others. 91 minus 89 divided by 95 minus 89. This delivers 0.33. Then 93 minus 89 divided by 95 minus 89. This delivers 0.66. 89 minus 89 divided by 95 minus 89. This delivers 0. 92 minus 89 divided by 95 minus 89. This yields 0.5. And 95 minus 89 divided by 95 minus 89. This yields 1. And then the last, um, 17 minus 15 divided by 18 minus 15 equals 0.66. 18 minus 15 divided 18 minus 15, this yields 1. 16 minus 15 divided by 18 minus 15, this yields 0.33. Then 15 minus 15 divided by 18 minus 15, this yields 0. And 16 minus 15 divided by 18 minus 15, this yields 0.33. Okay? So we have now normalized our initial data set, and now we can compare it. We can perform an analysis based on this normalization. Okay? Good. Any questions? No questions. Good. So the second step is to represent graphically the organizational dynamics okay. In order to do so, what we do is following strategy. So now we have a system. We have created a system in which, let's say, our axis, quality star, delivery rate star, and cost star are all the values are in a little cube. Okay. of side 1. Okay, so this is 1, 1, 1. Why? Because all the values are between 0 and 1. Okay, so if we say the calendar week is one point in space, it would be like the point in space 1, 0, 33, 0, 66. So if we represent calendar week 1, it would be 1, 0, 33 in delivery rate, so going up, 0, 33, and then 0, 66 going on the left, to the right, sorry, so this will be calendar week 1, okay? This point is the point 1, 0, 33, 0, 36. And calendar week 2 is 0.7, 0, 66, 1. So it's 0.7, somewhere here, 0, 66, somewhere here, and then going all the way to here. So this would be calendar week 2. Okay, so 0.7, 0, 66, 1, and so on. So we can say that our organization is moving from calendar week 1 to calendar week 2 like this, okay? And this could be already the dynamics that we're looking for. The problem is that making a three-dimensional representation is not always clear, okay? It's not always very understandable. That's why we're going to do following, okay? We're going to project the curve that we are dealing with in the organization into the simplex plane, which is the plane in which all points add up to 1. Okay, so this is this triangle. The characteristic of this triangle is that all its points add up. When we add up the coordinates of all the points in this triangle, they add up to 1. So this is called the simplex. Simplex, and the characteristic is that all the points or the coordinates of all the points are adding or add, better English, one. Okay, so for any point, for whatever point x, y, z, x plus y plus z equals 1. Okay, and if we project the blue curve into the red simplex, then we will get something like this. Okay, we will get a two-dimensional representation, and what we do is that we represent our triangle like this, okay, like this, and then we represent our curve, the organizational dynamics, like this, just in 2D, okay. This is the simplex representation. So this representation has several advantages. Okay, as I said, the first characteristic geometrically of this simplex is that all the points add up to 1. So in order to perform this mathematically, we need to make sure that all the points of calendar week 1 add up to 1. So we have 1, 0.33, and 0.66. In order to do so, we need to do a step 3, which is a temporal normalization. Okay, and the way to do it is to take the data. We have the delivery rate. We call it star star now. Cost star star. We take the data, so 0, 1, 0.33, 0.66 in the calendar week 1. Then we say 1, the value of the data of quality, divided by the sum. 1 plus 0.33 plus 0.66. Okay, and this is going to deliver 0.5. If we do the same for the others, you will see that the sum of the 3 will deliver 1. Okay, so if we now add 0.5 plus 0.165 plus 0.33 is, apart from the rounding, it yields 1. For calendar week 2, we do the same, 0.7 divided by 0.7 plus 0.166, no, 0.66 plus 1. This yields 0.297. Second, 0.66, 0.7 plus 0.66 plus 1. This yields 0.28. And the last is 1 divided by 0.7 plus 0.66 plus 1, yielding 0.42. For calendar week 3, we have 0.25 divided by 0.25 plus 0 plus 0.33 delivers 0.43. For the second is 0, and then for the last is 0.33 divided by 0.25 plus 0 plus 0.33, yielding 0.57. For calendar week 4, we have 0.1 divided by 0.1 plus 0.5 plus 0. This yields 0.167. then 0.5 divided by 0.1 plus 0.5 plus 0. This yields 0.833, and then 0. And for calendar week 5 is 0, 1 divided by 0 plus 1 plus 0.33, which is 0.75, and then 0.33 divided by 0 plus 1 plus 0.33, 0.25. Okay, so with this data, we are going to make the graphic representation of the simplex. As you see, all three data sets, all three data in the system for each temporal slice add up 1. Okay. Any questions? So now you need to pay attention. This is the difficult part of it. So once we have this, which is mechanics, okay, we represent the simplex, which is a tricky representation. Remember, we are here in the cube, and we are slicing the plane in which this cube touches the 3 ones of each axis. Okay, so we are taking, in reality, we are taking 3 axes in 1. Okay, so if we say, if we look from, like, let's say here, okay, to the simplex, we have on the lower left, we have Q star equal 1. Here we have our delivery rate equal 1, star star, I guess. And here we have our cost star star equal 1, okay? And one particular aspect of this geometry is that it has 3 axes in 2 dimensions, okay? So all the points add up to 1, but these points have 3 axes. So in the vertical, we can say that the delivery rate 0, 0, delivery rate star star equals 0, are all the points parallel to, are all the points in this line, okay? So this line is the point of all delivery rates 0, 0. And this line is the line of delivery rate 1, okay? So if you wish, the delivery rate, the quality, okay, the quality, let's say here, all the points with quality 0, quality starts are, 0, are here. All the points of quality 1 are here, okay? All the points of quality 0.5 are here, okay? In the middle. And the last one, so this is quality star star equals 0. And then the last one is here, coming here. So again, all the points of cost star star 0 are right there. Good. So this point in the middle, for instance, has quality star star 0.33, delivery rate star star 0.33 and cost star star 0.33. Okay. What do I know? Because all the three are touching each other in one point. So because the sum needs to add up to 1, I need to make 1/3 each. Okay. So let's look at the points for each week. First week is 0.5, 0.5, 0.165 for delivery rate and cost. Okay, so the point, all the points that have quality 0.5 are parallel to this line, and because this is 0.33 and this is 1, it's somewhere here. Okay, so this is the line of quality star star equal 0.5. All the points in this line have this value. And the line of delivery rate 165 could be used, but I prefer to use this, the cost 0.33, because I already have the point. So all the points that have cost 0.33 are parallel to this line and go through the middle point. Okay, so these are all the points with cost 0.33. Again, they go through the middle point because this middle point is our reference. So in the point where both lines cross, this is going to be calendar week 1. Just for the record, this point, this line will be the line with delivery rate star star 0.165. Okay, because all the points, the sum of all these three values need to add up to 1. Okay, is this understood? Okay, so for the second week, we go ahead. I'm going to take another color. We take 0.297 for the quality. So for the quality, I go and say, okay, all the points that are quality constant 0.297 are parallel to this line. But because this is 0.33, it's going to be somewhere going to 0 in the direction of the 0. So this is the quality star star 0.297. And then the other one, 0.28. Now I take the delivery rate. Okay, I take this. 0.28. It's going to be lower to this point, parallel to the lower line. Let's say this is the delivery rate, start 0.28. So where both lines cross is calendar week 2. What we are doing again is projecting the real line into the you see, it makes sense. Okay, this blue line, if this blue line, if we project it to the triangle, it happens to be what we have just painted. Okay, so what we have just painted is, let me put it in, let's say green, the dynamic of the system from calendar week 1 to calendar week 2. Okay? Good. So whenever we have 1 point was a 0. We take that because this is super easy. It's just in the axis. Okay, so we take the calendar week 3, the quality 0.43. So quality 0.43 will be something like this, a parallel line to this one. And quality 0.43 is going to be this. It's going to be touching the point of delivery rate 0. So that's line. That's the line we are looking for. Okay, so we go ahead and paint the movement from calendar week 2 to calendar week 3. Okay. Then the same thing, we take the one with a 0 and 0.167. I'm going to take another color, let's say this one. Okay, so the quality, the values of quality 0.167 will be somewhere here. Okay, quality star equals 0.167, and it touches the point of cost 0, which is going to be this one. Okay, so the calendar week 4 is going to be up there. Now we paint then the dynamic. And the organization moves all the way up. Okay. And for calendar week 5, we have the quality at 0. I need another color. I don't know which one to take anymore. Let's say I take this. Okay. So the quality is at 0, so it's going to touch this line. And then the I don't know, delivery rate is 0.75. So it will be something here. This is delivery rate start 0.75. So our line will be here, calendar week 5, touching the edge of the triangle. Okay, so we have this behavior. Or better said, if you want to follow the path like this. Okay. This is the way the organization is moving in its dynamics. Okay. So we have represented now the dynamics of the organization, the temporal dynamics. Any questions? No. Okay, so the problem with this, if I ask this in the exam, is that it takes a lot of concentration and time. Okay, so make sure you give yourself some example with new numbers. Okay, based on this, you just need new numbers, and you try to describe the dynamics of the organization with new numbers, because you need some agility. Okay, so the last step is the interpretation. the interpretation of the dynamics. Okay, so the rule is like this. The system is in alignment on a time point t sub j if the distance between t sub j minus 2, t sub j minus 1 is bigger than the distance between t sub j minus 1 and t sub j. Okay, so this is the formal definition. So let's look at the example above. Okay, so the distance between calendar week 1 and calendar week 2 is the distance between calendar week 1 and calendar week 2 is bigger than the distance between calendar week 2 and calendar week 3, right? You can measure it with a ruler. The result is that the distance decreases so we have alignment in calendar week number 3. Okay. The distance between calendar week number 2 and number 3 is smaller than the distance between calendar week 3 and calendar week number 4. Look at the graph, okay? This distance is smaller than this distance. And this is just, the organization makes a big jump. So there is no alignment in calendar week 4. Okay? And last, the distance between calendar week 3 and calendar week 4 is bigger than the distance between calendar week 4 and calendar week 5. So there is alignment in calendar week 5. Okay? the distance between calendar week 3 and 4 is bigger than the distance between calendar 4 and 5. Okay, in an ideal situation, is this understood? If I ask this in the exam, you need to argue correctly, okay? When you are managers, soon you will be, and you want to use this method, your ideal situation is to have something like this. So your system is in alignment when you are moving yourself within a little, let's say, circle. You can define how little, okay? So if you start moving yourself within this circle, this is what we call the threshold or the circle of alignment in the paper. Within this circle, the organization is under control, or in other words, in alignment. Remember the first lecture when we talked about organizational dynamics and alignment. The first lecture of the semester, I mean. Okay? So now you have a methodology to translate KPIs, management numbers, into something that can be interpreted and something where you can say, okay, I have my system under control, or my system is jumping around like crazy and I need to do something about it. Okay? Questions? Okay.